In this video, I'm going to be looking at DynamoDB. More specifically, I'm going to be focusing on how you can create single table models in DynamoDB. And I'm going to be doing all this with a real world example. Hi, my name is Abhay Bhargav. I am the CEO of a global application security company called V45. This is my personal channel, and I talk about everything from tech to the cloud to security. All the code and the tools that I've used for this video are in the descriptions. Please like, subscribe, and share this content if you find it useful. So DynamoDB is a very popular NoSQL database from Amazon's AWS. Now, one of the things that you should keep in mind when you're using DynamoDB, especially to build out real-world applications, is that you need to model them, right? Initially, when I used to work with DynamoDB, I didn't think about modeling at all, and that was the biggest mistake I made. If you really want to create real-world applications that are performant and efficient to work with, then you need to model your databases. And one of the models that we're going to be looking at is probably the most efficient and performant of all, which is the single table model. Now, regardless of the data sets, regardless of the views you have, all of your data would fit into a single table. And that's one of the best ways to get maximum performance out of DynamoDB. What I'm going to be doing now is we're going to be looking at a single table model, and we're going to be implementing it from scratch, from the get-go, from defining the use cases for the application to writing the code in DynamoDB and actually running that code against DynamoDB. So you're going to look at the whole length and breadth of doing a single table model in this video. So stay tuned. So let's talk about our use case a little bit before we go into our DynamoDB model itself. So we have developers creating multiple apps. Now, each of these apps goes into a VM. As soon as a developer commits this app to a repository, that repository pulls it and creates a virtual machine with all the necessary code and deploys all the necessary code. Now, once that virtual machine is created, our code actually takes a snapshot of that virtual machine and stores it on our cloud provider. Now, that's pretty simple, and it's great, especially if you're only managing a few applications. But what if you're managing a lot of different applications? That means that it creates a lot of different VMs, it creates a lot of different snapshots with the cloud provider. In many cases, you will have multiple versions of the same app getting logged as a snapshot in the cloud provider, which previously resulted in hundreds of different snapshots and images being stored in that cloud provider. So we needed a system to manage this better, which is why we came up with this when we wanted to use DynamoDB for this. So what we wanted to do was that we wanted to have an API that we could query that would talk to DynamoDB, that would give us the latest image. So let's say the developer creates a latest application that would get logged in our API and of course through that to DynamoDB. The developer would be able to query that from the API, which would be fetched from DynamoDB, and then test out the VM. So launch it into a particular VM, test out the VM and check whether it works correctly. And if that works correctly, approve that as the latest image that needs to be loaded every time that application is loaded. Now this is great because you can create multiple versions of the same app. So let's say you create one version on January 1st. Let's say March 1st, you create another version of the same app, you can log that as the latest version, and that becomes the latest version that all our developers use. And that becomes very easy for us to roll out. And you can also keep track of the previous versions, right? That's one of the better things as well. So let's say this application or this version of the application doesn't work out for some reason, you can always go back to the snapshot of a previous version of that same application. And that is all stored in DynamoDB, so it becomes much more easy for us at this point to actually manage this entire system. So let's start modeling, or at least start to define our model for the single table DynamoDB set that we have, right? So what we're going to do in this part is we're going to identify the attributes that are going to go into the table. And then we're also going to look at the most important aspect of DynamoDB modeling, which is access patterns. We're going to look at both these things and see how we can make it more efficient. So let's write out this in a file. Let's call this model.md. I'm just going to, and this is going to be available in the descriptions as well. So I'm going to say single table model DynamoDB. Now let's look at the attributes first. Now we're going to go name based in this. So when we go look at the attributes, we're going to go by image name or snap. So I'm going to be using the term snapshot and image interchangeably, right? So I'm going to use image or snapshot. They both mean the same thing. Now image is what we're going to be looking at. So image name is the thing that we want to access first. So image name is going to be a string. Now, when we store the VM, the snapshot or the image in the cloud, it gives us an image ID. So let's say, so that also needs to be stored once it's there in the cloud. That is an integer, right? So that's an integer value. We also have something called a configuration parameter. So every snapshot, when we want to restore a snapshot and actually run it as an app on a virtual machine, we need a configuration for that virtual machine, 2 GB, 4 GB, 2 vCPU, stuff like that. So that's going to be a string. And we also going to have a timestamp. So we're going to have something called a timestamp, which is going to be, in my case, I'm going to use Unix epoch. So that's going to be an integer. You can also use ISO formatted date string, which can also be a string, but I'm going to use epoch in this case, right? Now we have the attributes. Now it's pretty simple. These are the attributes we want to be able to capture. We may want to capture other attributes, but I'm not going to get into that because it's not necessarily very relevant from the perspective of our demo today, right? So let's look at the access patterns. Now access patterns are very important when you're doing DynamoDB modeling, especially single table modeling, because you are modeling this based on the kind of ways you are accessing that data. And that's why it's very important to write down your access patterns. What we like to do at V45 is not only do we write down the access patterns, but we also write down changes to those access patterns over time in a doc, like a Google Doc or some shared collaborative documentation that we can actually access and then make changes to it as the model evolves over time. So that's what we want to do. Now, this is not the model. This just is helping us identify what we need from the database for our applications use cases to get fulfilled. Let's look at the select aspects, right? So select is essentially where we are querying the database, right? So we're querying the database. We want to be able to select stuff from the database. So the first thing we want is to be able to get the latest version of a given image name. So if we say that, hey, give me application A or application B, we want to be able to get the latest version or the latest image or the latest snapshot of that particular application by name, right? So name, it's not ID. For me, the name is more important because the developer would select by name. So my access pattern is going to be by name. So in this case, you'll see that we're going to get that. We may also need to list out all the different image names that we have. So get the list of all image names in the system, right? So this is another thing. Again, we need to have a list of all. Now, the other thing we might also want to select for is we want to check whether there are existing images of the same name. So we want to check whether an existing image exists of the same name, whether it has versions in the same name. Let's say we're loading a completely new image into the database. That's fine, but let's say there's already an existing image. We need to version manage that image at that point. We don't need to create another entry. So perhaps that's going to be the case. So we're going to say get an existing image by name, right? So these are the three select access patterns that we have. Now you can also choose to model the insert and delete and all of those access patterns, but for the purposes of this video and for the demo, I'm just going to stick to the select patterns, and we're going to infer some of the other patterns from the select based patterns that we have. So now that we've captured our attributes and our access patterns, let's actually start getting down to a model, right? Now, one of the things that I love to do when I'm modeling is use an Excel spreadsheet or a Google spreadsheet. In this case, I'm going to be using a Google spreadsheet that I'm also going to be sharing with all of you. You can find that in the description as well. Now, the first thing let's do is let's start with the attributes itself. Now that we have the attributes, I'm going to create two mandatory fields that I need for every DynamoDB table. I'm going to use the PK and the SK. So the PK is essentially your primary key and the SK is your secondary key. All right, let's start modeling. Let's take up our first access pattern and see if we can make it fit. In fact, let's actually take up all three of our access patterns and see if we can start modeling based on that. So let's start with our first one, which is get the latest version of a given image name. Now, In DynamoDB, like I said, you have the primary key and the sort key. Now, the secondary key is actually called the sort key. It could also be called a range key. You could use different names. So I'm going to be using a composite key system, right? In a composite key system, one of the things you should understand is that the combination of the primary key and the secondary key or the sort key has to be unique. The combination of these two values have to be unique. If you are only using a primary key, and in DynamoDB it's also possible to only use a primary key, only the primary key has to be unique. In this case, since we're doing a single table model, it's always better to have a composite key because you can have a combination of values that can be unique and that can also give you different perspectives of that single table model. So let's start with our first example. Let's say the first one is get the latest version of a given image name. Now, let us say we capture our image name as the primary key and the latest version as v0, right? Now this works, and we'll also start to get our attributes in. Let's talk about our attributes. We have the config attribute, we have the image ID attribute, and we also have the created on timestamp, right? Now if I do, so v0 happens to be the latest version, v1, v2, v3. So this one the latest one can be this, the v1 can be this fetch, v2 can be this fetch, the image name. So essentially what you can do here is you can say, hey, get me the primary key of the image name and the sort key based on the v0, which is the latest version of that particular. So you can actually do a get for this. This access pattern also works for the third one, which is get an existing image by name. So you can say, hey, get me v2 of this image. So if I say v2, you will see that you can get it, right? However, you will see that this doesn't work for the second access pattern, which is list all the image names on the system. This access pattern doesn't work with this, because remember, to list, you have to be able to list out, you need to know the combination of this. So when I say this, I mean the primary key. You need the primary key for sure, and you need maybe a begins with on the secondary key to be able to query and get a list. But since you don't have the image name, you're not going to be able to fit it into this use case. So this is a problem. Now we have an issue. We do have a single table model, but out of our 3 access patterns, this works with only 2 of our access patterns. Now, can we make this work with our second access pattern as well? Absolutely. Let's continue further. Now we've seen that this particular model works with the first access pattern, which is get the latest version of a given image name. However, it does not necessarily work with this, because if I have to, when I query this, I can obviously get the latest version of the latest image name. So what I do is I essentially do query by image name, which is the PK. So I do the PK, which is image name, and SK, which is version 0. Version 0 being the latest version, right? So version 1, 2, 3, 4, those are all versions that are under version 0. So you might have the version 1 that is version 0 also. So which means that, let us say the first snapshot or image that you commit, that will become version 1 and version 0 at the same time. The next one will become version 2 and version 0. So that's how our logic is going to go. But this works, but the second one does not work. When I try and query this by the second one, I'm not going to be able to query it, because if I try and list, I don't know the image names to list. So, and remember, I have to query in DynamoDB. One of the things I have to do is I have to query with the combination of both this and this, the primary key and the sort key. So if I have to query with the combination of the primary key and sort key, I will not be able to do this. I'll not be able to actually use this access pattern. And one of the other things you should remember in DynamoDB is that you can't do a loosely scoped query on the primary key. So I can't say that fetch me all the primary keys that are like this or begins with this. I can do that with the sort key. So I can say fetch me all the images that are v0, right? That I can do, but I cannot do a combination of this and it won't be unique. So I have a problem now. So this model definition is not going to work. So what I'm going to do is convert this. I'll change this out. I'm going to remove this stuff. And I'm going to change this out. Let's see what we're going to do. That will fit both these use cases. So I'm going to say image. Now this is going to be a hard-coded string image. That's why I'm going to bolden it, and I'm also going to make it dark green. So this is going to be the primary key image. It's just going to be the word image, right? It's not going to be the image name. So here in the SK, I'm going to say v0 hash image name. So this is going to be the image name, right? v0 hash image name. And I can actually see, I can do v1 hash image name, v2 hash image name. And of course, I can have all my attributes, which is image ID, config, and of course, created on. Right? Now this is great because I can say, hey, DynamoDB, fetch me this specific image name. I can query this parameter, or I can say, so let's make this a real world simulation of sorts, right? So if I do v0 hash app underscore or app abc, and same thing with, let's make this image ID 1001 config 2 vcpu 8 GB, right? And created on 2020, whatever. So I'm just going to do it like this, right? So this is actually a timestamp. So I'm just doing it because I don't have a timestamp. So that would be v0, v1. I'm going to make it again app abc 2. Let's actually, yeah, that's fine. 1002 is fine. We can again copy this, paste it here. We can just copy this, paste it here. We can just do small change to this. We can actually make this 16 and 1003. So let's say this is the latest version of app ABC. So this, right? And I can change the attribute to here as well, 1003. Same thing here. And this we can also do created on this, right? So now let's take another application, right? Let's say I add another application, app XYZ. Okay, now this is 2001. And let's say it has one version, XYZ 2001. I'm just going to copy, and I'm just going to copy the same value here as well. Now let's say I want to fetch all images. Let's say I want to fetch, actually this was wrong, I'm just going to change this out. Let's say I want to fetch all images, latest images in our API, right, or in our database. It will fetch this and this. I can fetch this by saying, give me all images of type v0, or that starts with pk image and sk v0 hash or v0 even. So it will give me a list. It's going to give me a list of all that. Let's say I want to query a specific image. I can say, give me image of v0 of app abc. It will fetch this ID. But if I want to do image of all of these v0 apps, I can do that. I can do version control. Let's say I want to fetch v1s of something or v1 of another entry. I can do that. So this way I am able to actually manage my entire table in a very, very easy way. And my model is very straightforward because it's addressed most of my, at least the first two of my access patterns that I've actually planned for. Now let's look at the third access pattern, get an existing image by name. So let's say, so in this case, what it's going to be is going to pk of image, and let's change this to v0 of hash app abc, right? So this is going to be our access pattern. Now this is going to be sk dot begins with. I'm going to explain this in a moment. So you see what's happening here is we are querying the pk and sk. So you're looking at the queries that I'm going to be writing when I'm writing my code. So the first one is pretty simple. You're querying the specific pk and sk, and you're getting that one item. You're doing a get. Now get is the fastest fetch, so it would obviously do it the fastest. The second one is a query, which is also pretty quick. And remember, the objective that we want to do is avoid scans. Any which way we can, we want to avoid scans, because scans is this heavy query which is not very performant. So we want to avoid scans. So we're only trying to use get and query wherever we can. Right? So this is pk image abc, and this of course we're saying pk image escape begins with v0 or v0 hash, right? So this way it gives us all the latest images in that database, and we can paginate and do all of that stuff. I'm not going to get into that. The next one is going to see whether, let us see if it fits into our thing. So let's say we want to query v2 of something, right? So let's say we want to query v2 of a particular image. So can we do that with our same model? I think so. Let's look at how we could do that. We can fetch images with the pk, which is the standard stuff, and sk, we can do an equals check and say v2 hash app abc. That way we can get that specific image by name, an existing image by name. So now we actually have our entire model that we've done in a single table DynamoDB. So we don't have to go outside of this DynamoDB table at all to fetch anything. We don't have to go to another table. We don't have to join data from any table. Nothing of the sort. It's much faster. And remember, we have avoided the use of scan. We're only using get and query. So it's much, much faster than other access models that we've had, especially with multiple tables. So you don't need multiple tables to manage this at all. Now let's start writing some code to actually put this model into place and see whether our model actually fits. Now remember, there may be a few things we may still have not taken care of, so we're going to actually address that as we go along as well. So I think we've mostly thought of the issues, but there may be one or two issues that we have not thought of. Let's actually go ahead and figure it out. So what I'm going to do is I'm going to write some Python code where I'm going to implement all of the functionalities that we thought of, right? So first we're going to create some images, and then we're going to fetch the image by name. Then we're going to get the latest version of any image and get a list of all images, right? So our latest version of all these images. That's what we're going to do. So let's start with our first one, which is create image. We have created a table here called single table, and the single table right now is not populated, but we want it, of course, to be populated over time. And if you look at the schema of the single table, it has two attributes, mandatory attributes, which is your pk and your sk, which is your primary key and your salt key. That's what you've said as pk and sk, and the primary key is called the hash key and the sk is called the range key. First thing, which is create image, and we're going to pass in an image name and an image id. So the first thing we want to do is check if there is an image that already exists with the same name. And if there is an image that already exists with the same name, we're just going to have to increment a version of that image. If there is no image with the same name, obviously we create a v0 entry and a v1 entry for that image name. Now let's see how we do that. So first we have to do a check. So first we're going to do check for the image name. Image exists, right? Then we are going to increment version or create new image, right? So that's basically what we want to do. Now let's see how we can do that. How do we check for a new image? We need to check whether that image name exists, right? Now, if I look back on my model, you will see that it's not exactly going to work, right? You still see that it's not exactly going to work because, hey, how do we actually check for that image name existing? How do we check for that image name existing? We can check again based on v0 and v1 and then see whether we can add it. But let's say we want to fetch all the version numbers. So let's say there is an image that already exists and we need to increment that version at some other point. How do we manage that? Now you'll see that this is what's going to trip us up a little bit. And this is where our model has failed a little bit. We've still not thought of another access pattern, which is how do we get the older versions of existing images. Now we've thought of 3 access patterns in the first part, but now as we get into it, we realize that, we have not thought of this. We need to include this access pattern in our model. Now the good thing is we can do that. We've still not gone ahead and built our application, so that's a good thing to think about. So one of the things you should always do is sit together and do access pattern modeling very, very well before you go down the path of single table modeling, right? So now you'll see that this works for v0. You want to fetch the latest versions. This works perfectly fine. It also works for list of latest versions, but it does not work when we want to fetch the older versions of the same apps. So what do we do here? Now, instead of this, we can make this 2 different access patterns within the same table. So we can now say image name here for the PK, and for wherever there is v1, we can remove the additional parameter, right? So we can say, can even remove the additional parameter, and we can say, hey, give me the image name. So now what we did is we have actually changed our access pattern a little bit so that we can fetch the older versions of the same image. So let's say we have an image called app ABC. So this would become app ABC, which is the primary key, and we have older versions of app ABC, and we have the latest version of app ABC, which still fits into our existing pattern. We're not going to change our existing model for one of the patterns that we have, but we still have this fetching the older versions of the patterns with this, which is not going to work, right? So that's why we've made this change. In fact, what we should do is we should add an underscore, and I'll explain why we're adding the underscore. Now what we can do here in this pattern is say, hey, give me all the versions of app ABC. So we can say, give me image with pk app ABC that has an escape beginning with v underscore, and that we can count the number of entries that come back in that list and increment to that list if it's already if it's an existing image, right? If there is no existing image, then we can of course create v1 and then create a v0 entry. So for every single time that we need to check, we need to make sure that we have a list of all of this if there are any existing images. And if there are no existing images, then we create the v1 entry and we create a v0 entry like so, right? That's something we can do. v0 meaning the latest version, and v1, v2, v3 meaning we are managing the historical copies of that version as we go along, of that application as we go along. So now let's actually do that. So first what we want to do is check this. So we check whether the image exists by querying pk by the image name which you have sent. And we are going to query the sk.begins with v underscore, right? So that we are getting all the SKs with versions assigned to it. So it's querying this access pattern. Now let's actually get this to work. Now we have, so now what we did is we have actually changed our access pattern a little bit so that we can fetch the older versions of the same image. So let's say we have an image called app ABC. So this would become app ABC, which is the primary key, and we have older versions of app ABC, and we have the latest version of app ABC, which still fits into our existing pattern. We're not going to change our existing model for one of the patterns that we have, but we still have this fetching the older versions of the patterns with this, which is not going to work, right? So that's why we've made this change. In fact, what we should do is we should add an underscore, and I'll explain why we're adding the underscore. Now what we can do here in this pattern is say, hey, give me all the versions of app ABC. So we can say, give me image with pk app ABC that has an escape beginning with v underscore, and that we can count the number of entries that come back in that list and increment to that list if it's already if it's an existing image, right? If there is no existing image, then we can of course create v1 and then create a v0 entry. So for every single time that we need to check, we need to make sure that we have a list of all of this if there are any existing images. And if there are no existing images, then we create the v1 entry and we create a v0 entry like so, right? That's something we can do. v0 meaning the latest version, and v1, v2, v3 meaning we are managing the historical copies of that version as we go along, of that application as we go along. So now let's actually do that. So first what we want to do is check this. So we check whether the image exists by querying pk by the image name which you have sent, and we are going to query the sk.begins with v underscore, right? So that we are getting all the SKs with versions assigned to it. So it's querying this access pattern. Let's actually start getting our existing images and checking whether we have any images. I've added a couple of lines of code here to refer to the specific table that I want to talk to. So I've defined this as a Boto3 resource, and Boto3 is the AWS SDK for Python. So that's called Boto3. And we have also referred to a particular table, in this case called our single table. Now let's actually get our list of existing images. So what we're going to do is we're going to first write a query. Now remember, we need to write a kind of loosely scoped query, not too loosely scoped. We're still going a little more specific, but there is a possibility that since we're not doing a get, we're doing a loosely scoped composite query. So we're checking for the image name, and then escape begins with a v underscore, right? So that's what we're doing. So we're going to do table.query key condition expression. So we're going to say pk dot equals image name. Now remember, we're passing the image name, and sk dot begins with v underscore 0, right? Now if items in existing images and existing images dot get items. So what we want to do is we want to check whether there are any items that are returned. Then of course you are going to increment the value, else you are going to add a new entry, right? So let's see if there are any items that are returned. If there are any items returned, then we want to count, right? We want to count the list. So we want to get len, so we want to get num versions, which is equal to existing images, the length of existing images dot get items. Okay, so we're going to get the length of that, and we're going to add another entry to our database that has the latest version of that. So that is going to be the num plus 1. So our version is going to be, so let's say we have 4 versions already, then it's going to add the 5th version. If it does not have any version, then obviously it's going to go to the else loop. So if it has already 1 version, it's going to create a 2nd version. If it has 2 versions, it's going to create a 3rd version. That's what we wanted to do. Okay, so num version len of these items that are come back from our table. And then what we're going to do is we are going to make sure that we have some value that is returned. So currently we have the num versions. What we're going to do is add another entry. So table dot create item. It's going to be item. I'm just going to create the pk and the sk for now. So the pk is going to be image name, and the sk is going to be, so this is going to be the pk and sk. The sk is going to be v underscore, and let's actually format this sk a bit. I'm going to say num versions plus 1, right? So this is going to be the v underscore num versions plus 1. I'm not going to add any other attributes to this. We could add the created on and all that, but we're just doing it as a demo. So you could add the other attributes, but I'm not doing that. So we need to add this, and we also need to update the version with the latest one. So let's actually create the image ID, right? So let's actually add the image ID to this as well. We're also going to add the image ID to this, which is image ID. Whatever the user passes as the image ID, we're going to add to this. Okay. And we're also going to create the same thing as the V0, right? Now the V0 is going to actually adhere to our model. So let's look at our model for V0. So our V0 model looks like this. We are going to create a static image PK, and then we're going to add a V0 with the image name and the image ID. That's what we want to do. So this is going to be the image ID. Just all right. So let's move back to our code. We're going to create a PK with the static image, and we're going to say v0 hash, and of course we're going to change this to image name. Instead of doing this, we're going to change it to our image name. So instead of num versions, we're going to say image name, image ID, right? So that's what we're going to do. Now let's say there are no items that are returned. So at this point, let's say there are no items that have returned at all. Obviously, we need to still create some entries. So we're just going to copy these entries over, and we're going to create a v1 entry and a v0 entry with that same image ID. So we're not going to do any formatting here. Of course, we're still going to do formatting here because we want a v0. So if there are no existing items or no existing versions of that application, We're just going to create a V1 entry, which is the first version of that application, and then we're going to create a V0, which is the latest version. So the first version in this case is the latest version. Okay, so let's actually see how this works for us. All right, so now we've written some code to create our image. Now this code should create, not only check whether there's an existing image, it should also make sure that if there is no existing image, it adds the image, and if there is an existing set of images, it just increments the version of those existing set of images. Last time there was a small bug. I had actually not added the key, the key class, or created a key object with it. That's the reason the code failed. But anyway, so now I think this should work. Now let's open up the terminal and actually start to run this application. And I'm going to use the IPython so that's interactive shell with this particular code. Now when I do create image with an image name, let's call it app ABC is the image name, and ID 1001, you should see that it does not have a create item, put item. Oh, it looks like I made an error again. This is put item underscore item, put item. I thought it was create item, my bad. It's put item, and again, put. All right. Now, hopefully this should work. When I create item, you'll see that it probably created the item. Now let's look at our table and see what it actually did here. If you look at our data, let's scan our data, and you'll see that it's created 2 items as we thought, right? So now you see that we created 2 entries. The first version has been created. The PK is app ABC with V1 image ID 1001. However, it also creates the latest version. Now remember, the first version is also the latest version, right, in this case. So V0 hash app ABC image this, right? So 1001. Now let's create another version of the same app. So let's create another image of app ABC, this time with image ID 1002. So let's say our developer has made a change to app ABC and has committed a new snapshot of that, right? So new snapshot, it should, now let's see what happens to our data. If you scan your data, you will see now that our V0, the latest version, is changed to the V2 value. So it's found the V1. It clearly knows that V1 is the current version. It increments it to V2 and with the latest image ID. And now we have app ABC. The latest version of app ABC is the one that was created from the V2 value of this. So if I just create another value like this, let's say V3, you'll see now that it creates another entry with V3 of that particular application. Now this has actually been done. So we've actually been successfully able to add our entire image with that version control logic automatically built in, right? This is really cool. We actually have version managed images just by pushing in this through our API. So imagine that there's an API, I'm just creating versions and I'm just dumping it in, and it automatically handles the versioning, right? So it goes based on this and it identifies whether there are existing applications and it adds another version to that existing application. So you still have records that are maintained, at the same time you still have the latest version. So if somebody gets the latest version, they're pulling out this particular version of the app, which is the latest image ID, right? So this is really cool stuff. We've been able to get up and running with this model pretty quickly. Now let's implement the other access patterns as well. So now we're done with the create image access pattern. Now let's do list latest images, right? So I want to list the latest images of all types, right? So let's do it that way. So now what we're going to do is we're going to query this again. So for querying this, I'm going to use another query. So list images is going to be table.query key condition expression key of pk dot eq image. Remember, we are querying with the static image and we are querying the sk. So we're querying the sort key of sk dot begins with, and we're going to use v0 hash. So it begins, any image that begins with v0 hash, list it out. Okay, so now you will see that we should have our list images. So let's again do the same thing as we did before. In fact, now let's add another app to our list as well. Just to Python DynamoDB Single Table. Now let's create another image. Instead of app ABC, let's create app XYZ 2001, right? So we've created a new app as well. So if you go back to our table, you should see that we have our new app showing up here. It has a V1 right now. So we have two applications. In fact, let's add another application just to give it a list. ASDF. Let's create another app called ASDF. Let's use the ID 3001. So we have three applications. And let's also add some versions to all of this. ASDF, let's add another version to it as well. Now let's pull the latest images, right? That's what we want to do. So now if I do list, you will see that we have our latest images listed out. All the latest images are the only ones that are listed out. So you'll see that our image V0, V0 of ASDF, and V0 of XYZ. So now you have exact access to what you want, right? So you want a specific, if you want a list, let's say you want to populate a drop down with all the latest images, you just have to do it. And the reason why we have this composite key like this V0 hash, whatever, you can essentially just string split it and represent it in a drop down. You don't have to obviously represent it like this. You can just string split it and show that up as the app that you want. And internally, automatically, you can refer to it through that particular API. So it's really convenient. And you can see the access patterns are really fast as well. You'll see that it comes back pretty quickly. Even at scale, you'll see that DynamoDB gives you a really good read speed on these kind of single table modeled tables, right? So let's look at another use case of ours that is getting the image by version specifically. So the latest image by name. Def get latest image by name. Image name. Okay. So here we just have a single get. Now this is a very quick query. It should obviously be very performant and quite efficient. So we're just going to do table.get specific. I'm going to call this specific table.get key is equal to pk primary key is equal to image, and the sk is equal to v0 hash and the format. I'm just going to use f strings for this, just making it a little easier. Image name, right? So it's just going to give me the v0 hash image name. It's going to get this if it has any. So if item, so I'm just going to print out the specific.item. Specific.get key item. Right? So if there are any items, it will print it out. Otherwise, it's going to print none. So let's see how this works. Latest. I need to make that small change. Get item. Oh. My bad, it was supposed to be get item. Let me just rework that. And you'll see that we get the latest ABC. So let's say we want the ASDF, get the latest ASDF version as well. So this, as you can see, is really convenient, right? Now we are able to query multiple viewpoints within the same table. We don't have to join across multiple tables and make it very complicated. It's really simple. Now the last access pattern that we want is to also be able to get a specific image by name and version. So I'm just making these very contrived function names. Please don't use this as the basis to do it. So I'm going to say version. Now this is going to query our V1, V2, V3 type of focus, right? So this is older version, and I'm going to use another get table, get item query. In this case, we're going to do something a little different. We're going to say, so the image name is going to be the PK that we're going to query. The is something that we're going to query. So you see what I'm doing here is we're querying the image name and the version underscore 0, 1, 2, not 0, it's going to be 1, 2, 3, 4, whatever is not the latest version, right? So that's what this is going to be querying. And of course, we are going to print out the specific item. And let's actually get this queried. And you see we get the version 3 of that application. So as you can see, this was pretty quick, right? We were able to implement all of these different access patterns very quickly in DynamoDB, and we were also able to get it working because one, we had modeled it very clearly beforehand. We didn't start with those unnecessary questions and ambiguities regarding the database itself. And then we were able to actually get a model that works for us within the same table. We didn't have to split it up. So all of this is in a single table model. You're able to query it much more efficiently than you could. Let's say you had two different tables for this. It would have been much more difficult to query. And at the same time, we have completely avoided the use of scans. We have just used queries and get item requests, and we've completely avoided the use of these very non-performant queries like scan, right? That's one of the benefits of using a single table model. So I hope you enjoyed that video on single table model, and I hope you liked the demo. The code is, as always, available in the description. But I'm going to leave you with a few things before I end the video. One, I really learned all of this from looking at Rick Houlihan's talk at multiple AWS reInvent. So if you're looking for additional use cases, or if you're looking for more examples and a more technical demonstration of what DynamoDB can do, you should look at those talks. That's in the show notes in the description below as well. Also, you can look at, I use Dynabase for this particular video, but you should look at using NoSQL Workbench, which is a free tool from Amazon that can help you do modeling as well. So definitely take a look at that, and thank you. And I'm going to see you in subsequent videos. Thank you very much. If you like that video, you should like and subscribe to my channel. I'm planning to put out a lot more content on the cloud, on Kubernetes, and security as we go along. So thank you very much, and I look forward to seeing you in another video.